My name is Stefan Burzi. I come from northern Germany, from Schleswig-Holstein, northern Hamburg.
My name is Bernd Rohwedder. I'm teaching in Ludwigshafen at the Karl Bosch Gymnasium.
My name is Beate Brase and I am from Wilhelm Raabe Schule in Hanover.
My name is Carsten Schraut and I'm coming from Hennef in North Rhine-Westphalia.
NASA 747 Heavy, maintain 5,000 on your departure and contact Joshua Approach. Okay, 5,000 and we're switching 747 Heavy. Safe flight, good night.
As a physics teacher, I love physics and astronomy, and my pupils mostly, they sometimes have problems with physics, but they love astronomy, so I try to teach physics in astronomical contexts.
So I have many interests because of my profession as scientist and teacher. So I want to bring the latest research to my students and the modern technologies.
My students and I said when we went to the stratosphere, I could call me a stratonaut already.
If I would be asked what the most fascinating aspect of it is, I would say that this incredible way in which they compensate for vibrations on this airplane.
100 and maintain flight level 370.
It's very fascinating and amazing to sit in the cockpit and see how many switches and levers the pilots have to use and how it could be that a plane could fly so and watching a star.
Below you can see aircraft and environment. So now we are up at 41,000 feet. The telescope is very low, it's just at 33 degrees. You could also see when you look to the back. And here you see the inflation of the pressure of the vibration isolation system.
Tonight we're observing an asteroid. It's called 121 Hermione. It is a very large asteroid. It's about 316 kilometers in diameter. It's one of the larger asteroids in the asteroid belt.
The telescope, the most fantastic thing on this plane, because it stands still in space and the plane rotates around the telescope. I find this always fascinating.
What we don't know is how old the stars are, if they're really, really young. And that's exactly what SOFIA is going to help answer, because by measuring their dust properties, we'll be able to pinpoint somewhat precisely how old they are. The Spitzer Space Telescope has observed this target before, but the stars are so close to each other that Spitzer couldn't resolve at the mid-infrared wavelengths that I'm interested in, and only SOFIA can do that. Really, only SOFIA is the only thing on the planet right now that can do that.
My students have to learn about SOFIA, and in the next step they have to do videos that we will perform on a World Wide Web, so that every teacher and every student get a fingerprint for the SOFIA's mission.
Alright, so this is the first little bit of data that we're getting here, and actually it's kind of interesting. We are seeing some real features here. This feature here is ozone absorption, and so this feature right here is real. That's sulfur, and this right here, this overall hump is probably real. It's possible that the underlying hump here is real too, both of which might be due to silicate. And we actually have more filters than we have slots in our filter wheels, and so we allow the community demand to drive what filters we have available.
My students are very interested in the flight. I will show them what you have to do to take such a flight.
So what is your theory for the origin of water on Earth?
I think for how Earth got its water, it's probably a combination of both being formed by things that had water in them, and then also late implantation by comets.
And I would really like to thank on this occasion NASA, ESA, etc. for the possibility of being here and going through this wonderful experience.
Turn it right to 100 and flight level 370. Okay, see you later, guys.
Roger, thanks for your help. See you.